Okay, people, here's the rest of the questions from page 13. So this is number 6 through 9. They're all pretty similar. Now, the other day we started with a couple of these where you compare the mass and the time. And remember, always start time at 0. And then your units can be either the number of half-lives or it could be the years, seconds, days, whatever the half-life might be, and they just keep multiplying it. Okay, and for the Regents course, the number of half-lives will always be an integer, a whole number. Okay, so 2, 3. You won't have decimal half-lives. Okay, but again, we're trying to prepare you for the next course, so just get ready for that. And that's where your calculator can help you in your math skills. Okay, but for these are all pretty straightforward. So in the first case, we had nitrogen 16 grams. The given amount of time was 21.6 seconds. I looked up the half-life, table N, 7.13 seconds. I made a chart. This time I went horizontal. Okay, and remember, start at time 0. So every time one half-life goes by, the amount that's still radioactive is half as much. So 8 grams, 4 grams, 2 grams, and your answer should be 21.6. I'm sorry, your answer should be 2 grams. There's the amount that's still radioactive. All right, next one, thorium 232. Okay. Given amount of time, half-life I looked up. Now it looks a little weird with the scientific notation, but again, this is an integer multiple of that. This is 7 times. Now let's see if I left myself enough room here. So I'm gonna, rather than write all the scientific notation here, I'm gonna count off the half-lives. 1, 2, 3, 4, 5, 6. Not quite enough room, but we'll figure it out. So keep dividing by half. 128, 64, 32, 16, 8, 4, and your ultimate answer after 7 half-lives, which I ran out of room for, would be 2 grams. So 2 grams is the answer. Okay, same as up here. All right, next one, number 8 is iron 53 with a half-life of 8.51 minutes. 34.04 minutes is 5 half-lives. 4 half-lives, excuse me. So we're gonna make our chart have 4 spots here. 1, 2, 3, 4. So again, I'm going to put the half-lives in here rather than the number of minutes. Okay, and all we're going to do is divide by half 4 times. So 250, 125, 62.5, and then 31.25 grams will be what's still radioactive after 4 half-lives. Okay? Last one on this page is potassium 42, 24.8 hours. The half-life is 12.36 hours. So you can see, I think we're going to go 2 half-lives here. Again, I'll count off. This time I'll do it by hours just to show you the difference here. So after 12.36 hours, 1 half-life, we would be down to 50 grams. And again, another 12.36 hours goes by. It's about 24.8. It might not be exactly perfect, but it's close enough to 2 half-lives. So another one down to 25 grams, still radioactive. Okay? So that should take care of page 13. You should have all those filled in. And you can send those in. And we'll have not much left, but we do want to talk briefly about fission and fusion. Fission is a very important source of energy, and it's where you're getting most of the electricity in upstate New York. So we do want to talk about that somewhat. Okay? So hopefully that's helpful, and stay safe. Thanks.